This problem is also the problem related with the conservation of the energy. You need to understand what is the elastic potential energy, and at the same time you should be also knowing the inelastic collision and the principle of conservation of the linear momentum. So in this case we're going to use two physics concepts. The first one is the principle of conservation of energy, and the second one is the principle of conservation of linear momentum. What is this problem asking? So you have an 8-gram bullet, and the bullet is shot into a block, and then both starts moving, and then compresses a spring. When the spring gets compressed, it moves by 8.7 centimeter, and you know the information about the spring. The spring constant is 2400 Newton per meter. From this information, you need to calculate what is the initial velocity of the bullet. So when the bullet and the block moves together, when this bullet and the block moves together, it compresses the spring. So that means all its kinetic energy changes into the potential energy. So when it comes back, all it does have the kinetic energy. But once it hits the spring, all the energy is now changing into the potential energy. We call that as an elastic potential energy. So let's first use the principle of conservation of energy. So the kinetic energy this kinetic energy is a bullet and block together. This is equal to the elastic potential energy. This is equal to elastic potential energy. Okay, what is the kinetic energy? You know half mv squared. In this case, you have the two masses, the mass of the bullet and the mass of the block. So just keep in that. So I'm just considering the m, the small m is the mass of the bullet, and the capital M is the mass of the block. The bullet mass and block mass, and the velocity is given right here. So its kinetic energy would be half m plus m v square. What is the elastic potential energy? The elastic potential energy is half k x squared, and the x is the compression. In this case, it is given 8.7 centimeter. So the compression, the x is 8.7 centimeter. You need to change this one to the meter because everything has to be in SI system. So in order to change the SI system, you just have to divide it by 100. So once you divide it by 100, you'll get it 0.087 meter. Okay. So now just plug in all the values into this equation. The v square is equal to half cancels out. So you have k x squared divided by m plus m. So the v is equal to k divided by m plus m square root times x. and just plug in all the numbers here. So I'm doing all the calculation here. So put the information here. What is the value of x? The value of x is 0.087 square root. What is the value of m? The k. The value of k is given is 2400 Newton per meter. This is the value of k. 2400. The mass of the block is 4 gram. The one is 4 kilogram, and the other is, this mass is, the bullet mass is 8 gram. The mass of the bullet is 8 gram. You need to change this one into the kilogram. So how do you do that? You just have to divide it by 1000. So this will be 0.008 kilogram. So I'm just plugging all the numbers here. Okay, so this mass, and then solve it. Once you solve it, what you get is 2.17 meter per second. This is the velocity of the block and the bullet together. Okay, so both bullet and the block moves at this speed. And now you need to find it out what is the velocity of the bullet. And now we're going to use the conservation of linear momentum. I have to erase this side. If you're taking notes, you may pause the video at any moment and then take the notes. Okay, so I have to erase this side here. Okay, now, so let's see what happens before this situation. So you have a bullet. This is the bullet, and then you have the mass here, the block, and then this one is it was at rest, and then once it hit, both starts moving together. This bullet and the mass. So let's say the velocity of the bullet is the v bullet, and this one was sitting stationary. So this is the rest. The velocity of the block is equal to 0, and this velocity is v, as given there, and we already found it out. So what is the principle of conservation of momentum? It tells you this is the initial momentum and this is the final momentum, and both momentum has to be equal. So this is initial momentum. And this is the final momentum. Final momentum means after the bullet hits the block. And this momentum has to be equal. What is the initial momentum? The momentum is mass times the velocity. So the mass of the block, which is the m, and the velocity is v bullet. What is the mass? The mass of the block, but its velocity is 0. So this initial momentum is 0 of the block. And this one has both masses, the mass of the block plus the mass of the bullet, because they are together. So the total mass is m plus m, and the velocity is v. So just have to solve for the v bullet. V bullet is equal to m plus m times v divided by mass. Let's plug in all the numbers here. What is the mass of the block? We already know that the mass of the block is 4 kilogram. That's the 4 kilogram. And the mass of the bullet is 0.008. 0.008, and again this mass is 0.008 times the velocity is 2.17. Say here 2.17. 2.17. Again, use your calculator, and the answer you will get is the bullet speed is 1067 meter per second. This is 1067 meter per second. So this is the bullet speed. Okay, if you're just taking a snapshot, just take it.